This is the first in the Unit 13 discussions that I'm going to record for your use, and the first thing that we are going to look at is this idea of inducing an EMF by the relative motion of a conductor and a magnetic field. Inducing an EMF by the relative motion between a conductor and a magnetic field. We're going to use three sources or three different tools to discuss this. We've got our notes, so one needs to make use of the notes. You've got these notes here that are here. We have also got our applet, which you can get from the FET site, FET simulations, and there are also the PowerPoints. There are three PowerPoints for this section, so we're going to use all three of these. Okay, firstly, starting with our applet, it was noted, and this was a great discovery, that when you have a moving magnetic field, so in this case over here we have a magnet and we can move the magnet and therefore change the magnetic field, that when it was close to a conductor, it actually induced an EMF which induced basically a current moving through a conductor. So as I move this magnet to and fro, as the applet shows, there is current, there is the moving of charges through the conductor. This works the same way if you move the conductor and the magnet remain still. Now what this has led to is something to turn a conductor in a magnetic field that produces electric current, and that is the whole basis of a generator. So over here we have a situation. I'm just going to discuss it a little bit in regard to the direction of movement, and we're going to use the right hand rule to do that. So, well, perhaps I should let me use the PowerPoint actually, because there's a nice diagram here that we can use. So looking at this situation over here, we have got a horizontal magnetic field. So our magnetic field is moving in this direction like that, and we've got our conductor going down. Now I want you to imagine, in this diagram we have got negative charges, but I want you to imagine the positive charges. So I'm going to make these positive, and we're going to imagine these charges moving through that magnetic field. Now we know with the right hand rule, the right hand motor rule, that if you've got your charge moving downwards and your magnetic field moving across, we put our fingers in the direction of the magnetic field, and we put our thumb in the direction of the moving positive charge, and the palm of the hand will be in the direction of the force that will be exerted on that charge. So let's do that. Just do that with me. You've got the magnetic field is going in the direction of the fingers, the thumb pointing downwards. Can you see your palm is actually pointing in this direction here? This will be the direction of the current that flows. So in fact, this conductor, as it is pushed down, creates the effect of charges moving through a magnetic field, which causes a force to be put on those charges that actually moves the charges through the conductor, creating a current, creating an induced magnetic field. Thank you. That is the first in the series on this Unit 13.